Today, I'm going to talk about isolation level in MySQL. The common ones being read committed and repeatable read. We will cover some of the little quirks in MySQL, specifically how locks can affect read. For the locks, we will cover gap lock and next key lock, which will be applicable for range query. We will also touch upon MVCC. And we will finish off by demo how to reproduce phantom. You may think you know phantom, but you don't. So let me start by giving a demo on a little quirky behavior in MySQL and see if you are surprised by that. Let us see an example in MySQL. We have a table here called T. It has 3 columns. Column ID, it is primary key auto increment. Column name, it is of type varchar. It is not an index. Column amount, it is of type int. It is an index. This is default isolation level, which is repeatable read. I have started 2 clients. Let us check what data do we have in our table. What I'm going to do is I'm going to start a transaction. I'm going to read inside the transaction. We only have 6 rows in our database. To demonstrate the concept of repeatable read, I'm going to make a change in client number 2 and see whether that change affects my read in client number 1. So I'm going to also start a transaction. Let's read what we have. It's the same thing. Now I'm going to make an update. Maybe set amount equals to something negative. I'm going to update where ID equals to 2 from 100 to negative 100. Now I'm going to commit. Now my client number 2 has made an update. If you read it, since our change has been committed, so to the outside world, this row reads negative 100. But if you go back to our client number 1, because we are in the middle of a transaction, if you were to read it again, the value does not change. Hence the word repeatable read. You can repeat your read. If we were in a different isolation level, say read committed, you would have read the committed data that would be negative 100. But because we are repeatable read, you can repeat your read. But that being said, there are more nuances to repeatable read than what you think. For example, if you were to do a locking read, this would have given you a different result. So you can add this for update, which adds a lock for your read. And you see all of a sudden, our base result is negative 100. Interesting. You can just keep doing these reads back and forth. Your normal read give you 100, but the locking read give you negative 100. I think this really begs the question of repeatable read, exactly what does it mean? What kind of read can you repeat and what kind of read can you not repeat? To answer the question, we need to step back and look at the fundamentals. Before I start, I'd like to reiterate that the behavior I'm talking about here only applies to MySQL InnoDB engine. Let's talk about read committed versus repeatable read isolation level. These are the most common isolation levels in databases. And in InnoDB, the default isolation level is repeatable read. Before we delve into the details, what does the word isolation level mean? Isolation level describe how transactions affect other ongoing transactions. Think of a transaction as a bubble. I'm a transaction, I'm in my own bubble. You're a transaction, you are in your own bubble. You do you, me do me. We do not affect each other, we are isolated. For a stricter isolation level, let's say you commit some change, I'm not going to see them because it's strict. I am isolated from your change. For a weaker isolation level, whatever the change you make, I can feel it, so I am less isolated. So that's the intuition for the word isolation. To analyze an isolation level, it's important to analyze 3 scenarios. Non-locking read means just a normal read. Locking read or write, meaning when you read but you add for share or for update, which applies lock for your read. And phantom, meaning read multiple rows. We are interested in read committed and repeatable read. And repeatable read being the default isolation level for MySQL InnoDB engine. Okay, let's talk about read committed. What's the intuition for the word read committed? The word is very self-explanatory. Read committed means transactions always read committed version of the data. What is the implication? If the data keeps getting committed, then I keep reading it, I'm going to keep reading different data. Hence, I cannot repeat my read. So read committed does not provide very strict isolation because committed change from other transactions can affect my read. So I'm not that isolated from other transactions. A stricter isolation level would be repeatable read. The word repeatable read is also very self-explanatory. When I start my transaction, I read something. Even if other transactions keep committing on this data, I can still repeat my read while ignoring the change by other transactions. Hence, repeatable read. I can repeat my read. So for repeatable read, you are reading the snapshot at the start of the transaction. So it's almost like you take a picture. That's what you will read for the entirety of this transaction. Now, this is where it gets interesting. There are two things that are interesting. The first is you notice each data exists in multiple versions. You have committed version, you have all the past versions. Each transaction reads different versions. This concept is called MVCC, multi-version concurrency control. Later, I will have a dedicated slide for that. But for now, just understand that each data has multiple versions. So far, we've only been describing non-locking read. What's a non-locking read? All the reads by default are non-locking. Just go and read it. There's no lock. The other interesting thing is, once you do a locking read or a write on a row, the behavior change. A locking read always takes lock on the committed version. Even if in repeatable read isolation level, you will always read the committed version. So we can see there's a clear difference between locking read and non-locking read, especially in repeatable read isolation level. If you do a non-locking read, you read the snapshot at the start of the transaction. But if you do a locking read, you read on the committed version. If you still recall the demo I did at the start of the video, I alternate the read between select star and select star for update. They give different results. So now that makes sense. So far, we've talked about non-locking read and locking read. Before we move on to Phantom, I want to talk about MVCC. MVCC stands for Multi-Version Concurrency Control. Each record exists in multiple versions so that readers don't block writers, writers don't block readers. What does this mean? Let's analyze something more trivial. Readers should never block readers. Writers should always block writers. Right? When I read something, I have no side effect. It shouldn't block anybody. Okay. Writers should always block writers, right? To prevent race conditions. What about read and write? How should they interact? You say, of course, read and write should not block each other. Because if they do, that would be very slow. It's bad for performance. But in order for that to happen, we need to have multiple versions for the same record. Why is that? Let's just say, what happens if there's only one version? If there's only one version, there's no isolation level at all. All reads are dirty, right? Because there's only one version. To prevent dirty reads, you have to make read and write block each other. And now since we don't want to do that, we have to have multiple versions. When you have multiple versions, each of these versions are identified by the transactions that created them. each transaction have transaction ID. Later transactions usually have higher transaction ID. This makes sure when we start a transaction, if the version's transaction ID is smaller than my transaction ID, I can see it. If it's larger, I cannot see it. Which is why you can say, when you start a transaction, you can read a snapshot of the current database. And when I was trying to do this, it's like taking a picture, taking a snapshot. So intuitively, MVCC is a solution that gives you both performance and isolation. It gives you performance because read and write do not block each other. It gives you isolation. You always read the same, regardless of what the other transactions do. Do bear in mind, this is only a high-level overview of MVCC. In practice, MySQL and Postgres implement differently. And even in MySQL, MVCC is done differently between primary index and secondary index. MVCC is a huge topic. It deserves a video of its own, so we will not go into detail here. And finally, we can talk about phantom. Phantom means in the same transaction, the same query yields different number of results. You issue a query, it gives you 2 rows. Later, you do the same query, it gives you 3 rows. You read different number of rows. One of them is like a ghost, like a phantom. So does phantom happen in repeatable read? Now, I want to make absolutely clear, the behavior I'm describing here is only for MySQL InnoDB engine. For MySQL other engines and Postgres, they have different behavior. So for MySQL InnoDB, repeatable read isolation level, phantom read is not possible, but phantom write is possible. These are not formal terms. So let me explain what do I mean by phantom read and phantom write. Phantom read means in my transaction, I'm not doing any write. I read a certain number of rows. I'm not writing anything. And later I read again. I always get the same result. So phantom read is not possible. And what is phantom write? You guessed it. I read a range, and then I made a write which affects this range. And later, when I read the same range again, I read a different set of results. So phantom write is possible. Now let's see some demo. First, I'm going to demonstrate in repeatable read, phantom read does not exist. So let us start a transaction in client number 1. I'm going to select a range, let's say between 250 and 550. So that gives us 3 rows. Now in client number 2, I'm going to insert a value in between that range. And I'm going to auto commit. So I'm not going to start any transaction because by default it's auto commit. So in my client number 2, I inserted a new value where amount is 310, which falls into the range between 250 and 550. I auto commit. So let's see what does the database look like. Now I come back to client number 1 because we are testing phantom read. So I'm not going to do any write. So let us read again. We have the same results. So phantom read does not happen. And if you were to go out of the transaction and you read again, obviously the value will be there because you are outside the transaction already. In order for this demo to be consistent, I'm going to delete the new row. Let me read it again, and the row is gone. Before I demo how to actually produce phantom write, let me talk about another scenario where MySQL prevents phantom. This is the example that's shown in the official documentation. So I'm going to start a transaction. I'm still going to read the same range, but I'm going to say for update, which applies a lock for the range. Now in repeatable read isolation level, this will apply a gap lock. When we have a gap lock, it will actually prevent insertion in between this range. So in my client number 2, I'm actually unable to do the same insertion. So let's say I still want to do the insertion on my client number 2, and you see it is blocking because of the gap lock. So MySQL does prevent phantom in this scenario. When you have a locking read, the gap will be locked, which prevents insertion or deletion from that range. So let me exit from the SQL statement. There's one more thing. When we lock this range, just now I call it a gap lock, but the more precise term is actually next key lock. Just think of it as a gap lock, meaning we are locking the range between 250 and 550. But in reality, it does not lock between 250 and 550. It locks between 200 and 600. And let me just show you real quick. I start a transaction, I select the same range, and in my client number 2, let me insert 210. See, by right, 210 fall out of this range, but it will actually still block. This is because, according to the official documentation, InnoDB does not remember the exact where condition. It only knows the index range that were scanned. The locks are usually next key locks that blocks insertion into the gap immediately before the record. So what does it mean? InnoDB does not understand the exact where condition. So InnoDB doesn't know this range. It only knows the index range. And what is the index range? We have a list of values. The range it will lock is the next key lock, meaning for 250, you look one key in front, so that's 200. And for 550, it goes one key above that, so that's 600. So for this statement, the real locking range is between 200 and 600. And hence we call it next key lock. The word next means you find the next key outside of the range. Or in another word, the minimum set that's bigger than the where range. Just to reiterate, the reason we lock this range is because of this for update. If you lose the for update, we do not lock the range. And I think finally we're ready to move on to actually reproduce phantom write. So how do we reproduce that? We have the same number of rows. Let me start a transaction. It's a normal read, which does not apply any lock. Now in my second client, I'm going to insert value into the range. I auto commit. Let me read it. The insertion is successful. Let me go back to client number 1. No phantom, no problem. Now I'm going to do an update to this range. I'm going to raise all the amount to amount plus 1. So set amount equals to amount plus 1 in this range. So this is an update. So here I call it phantom write. So you are writing something. And you see, oh, there's a red flag. Rows matched 4, changed 4. That's a little fishy. There are supposed to be 3 rows. How come you have 4 rows now? It's because my client number 2's insertion is affecting my update. So let me read it again. A normal read, mind you. Oh, all of a sudden we have this value. That's the phantom, that's a ghost. So why is phantom happening? The reason is pretty straightforward. Update or locking read always applies on the committed version. And this new value is committed, so the write will take effect on that range. In another word, a write operation in repeatable read is always read committed. It's not repeatable read. I want to give credit to the answer here. InnoDB does not support repeatable read for locking statement, including any of the updates. It always works on the committed version as if the isolation level were read committed.